So welcome to this video. This video is going to carry on looking at rivers, and in this particular one we're looking at what a hydrograph is, and by the end of this you need to know what discharge is, what are the key features of hydrograph, and what are the factors that affect a hydrograph. But before we do that, let's just quickly recap on last lesson. So have a look at this, have a look over here where you can see it says human physical factors, and can you go through each of these and just see how much you can remember. How do they affect the water getting into a river? So how does urbanisation affect it? So for example, urbanisation means lots of impermeable surfaces, so there's more surface runoff. So just stop for a second and go through each of these in turn, and just jot down how they'll affect a river. In particular, will be more or less water travelling overland flow. Okay, how do you get on with that? So we've done urbanisation already. If you've got vegetation, remember that's what intercept the rain or catch it on its leaves, and that will slow down the flow of the movement of water, so there'll be less water getting into the river. Water abstraction, that's going to mean taking water out of the river. Well, if you take water out of the river, there'll be less in it. Temperature, higher it is, the more evaporation. Rainfall, well, obviously the more rainfall there is, the more water there's going to get into a river. The previous weather conditions, what we call the antecedent conditions. So if the ground's saturated and it rains, less water is going to infiltrate into the soil, more overland flow, there's more water in the river. And then geology, porosity and permeability, and they're kind of linked together. Porosity is how much water the rock can hold, and permeability is how easy the water can flow into and through that rock. So if you've got highly porous rock or highly permeable rock, then more water is going to go into the ground, into the rocks, and less water is going to flow over land, and the water is going to get to the river slower. So having looked at factors that affect water sort of flows in a river basin, then it comes on, we need to look at this idea of hydrographs. And hydrographs are basically how much water there is in a river at a given point. And just to put this in perspective, just so we can see how we've got to this, it really is linked into this final section about flooding. And basically, you can see this link between the water cycle, the amount of water moving around in a river basin, and the amount of water in a river. And what a hydrograph does is it measures the amount of water in a river. And what we're interested in is when is that river going to flood? When there's going to be so much water in the river, that it starts to flood. And the way we look at that is through this idea of a hydrograph. So let's have a look and then at taking this forward and seeing what we can learn about them. Now, before we can actually learn about hydrographs, we need to know what the word discharge is. So just stop for a second and think, what might be a river's discharge? So discharge is the volume of water in a river passing by you at a given time. What on earth does that mean? Well, it's measured in something called cumex, and that stands for cubic meters per second. And if you look here, you can see where cumex comes from. And what it basically means is, if you stand next to a river, how many cubic meters of water will pass you in a second? So if it's a piddly little stream, it might be sort of 0.1 cumex. If you stood next to the Ganges or something like that, it might be 300 or 400 or even a couple of thousand cubic meters of water travelling past you every second. And that's what discharge is. It's the amount of water travelling past you at any one point in a river. So that's when we're talking about discharge, we're going to be talking about this a lot, that's what the key word means. Now, what a storm hydrograph does is it actually shows you how discharge changes over time. So have a look over here, you've got a storm hydrograph, and you can see this graph here, and you've got discharge, that's the amount of water in the river flowing past you, and you've got time, and you can see that what it does is it does this. It rises and rises and rises, then it gets to a maximum, we call that maximum peak discharge, and then it falls and falls and falls and falls. Well, what would actually cause a river to rise and then fall? To rise, it needs more rain, it needs more water. And so what you can see here on a storm hydrograph are these bars. Now these bars are what measures rainfall. Okay, and you'll see that, again, it's only a short period of time that it's raining for, but as soon as it starts to rain, then the water starts to rise. And that makes perfect sense. If you think about it, if it's been heavy rain, you expect the river to be higher. If it's been in the middle of a drought, you expect the river to be lower. Now we split the water in a river into two. We've got what's called the base flow. Now this is the water that will get into the river through the soil, through the ground. And actually, that's really important because if you think about the River Thames or something like that, it doesn't dry up just because it's been dry for a month. Okay, that's water that takes a long time to get there. But if you look at this, it doesn't really go up massively. It goes up a bit and it goes down a bit slowly. Yeah. All the damage, if you're talking about a flood, is from this. Okay, and we call this the storm flow. Now this water here gets into the river not through the ground or the rocks or through the soil, but overland flow. And so what happens is, because overland flow is the fastest, it means water flowing over the land, it's sometimes known as surface runoff. Because it gets into the river quickly, that means that it's that water which makes the river rise quickly. And because it's getting into the river quickly, it won't stay there for very long, so eventually it will disappear very quickly and you're back to base flow. So that, okay, is when we're talking about storm hydrograph, the sort of key bits. We call this bit where it's rising, because we're unimaginative, the rising limb, and we call this bit the falling limb. And like I say, the bit at the top where it hits the maximum amount of discharge, that's when the river is at its highest, is what we call the peak discharge. And we also, if you notice, measure the time between the rainfall and the peak discharge. And technically that should be the maximum rainfall and the maximum discharge, and we call that the lag time. So that arrow is actually slightly in the wrong place. It should be on that bar there. So that's basically the key terms. And again, if you have a look here, okay, what you'll see is you've got another diagram here. This one has got the lag time done correctly. Again, rising limb, falling limb. You notice it's got the base flow here. That makes that storm flow here. And again, you'll notice a number of hours here. So you've now got a worksheet which has got some tasks on. You've got one of these to label. You've also got a number of key terms to match up. Okay, in fact, they're the key terms I want you to match up. So I want to stop the video, have a go at all of those, and when you're ready, we'll go through them. Okay, so I hope you've had a chance to go through them. Let's go through them quickly. So discharge is the volume of water passing a given point. Remember, it's measured in cubic, we'll come to that later. The volume of water is the amount of water in there. The velocity is the speed, which we measure in meters per second. Qmax we've already talked about, and that will be the volume times the velocity, okay, which is a measurement of discharge. So the cubic meters per second flowing past you. Peak discharge, we talked about the maximum flow during the storm when the graph's at its highest. The lag time is the time between the peak rainfall and the peak discharge. The rising limb is when the discharge is increasing on the graph. The falling is when its discharge is decreasing. The peak rainfall is that heaviest point of the storm, and the normal base flow is the discharge that the river gets from in sort of normal conditions, i.e. the water it's getting from ground flow and through flow, not from overland flow. So just stop and check you've got those right, because one of these lessons where there's some really important terminology. You need to make sure you're secure. And when you've got that, let's move on. Okay, so again, say you had this, and hopefully you've got this correctly labelled. You'll notice that that is measured in millimeters, and that's going to be precipitation. This one over here is going to be peak rainfall. That's the rising limb, the falling limb. We've got a peak discharge. We've got base flow. We'll have discharge, or Qmex, meters cubed per second, and we've got the lag time. So again, hopefully you've got that all labelled. And in fact, there you go, you've got the labels. Now, one thing that always surprised me was that actually geographers use this word flashy. It's actually a technical word. And a flashy hydrograph is one which has got really short lag time. And what it means is it rains and there's an almighty flood that's really quick, and then the water's back to normal. Whereas you sometimes get what's called a delayed hydrograph, or sometimes known as a slow onset hydrograph, where it might rain and it might actually be hours, weeks, even months, well, probably not months, but certainly days or weeks before the river reaches its peak. Doesn't mean it won't flood, it just means it will take a longer time before it starts to flood. And what we need to know as geographers is what makes some rivers flashy and makes some more delayed or slow onset rivers. And that's what we're going to look at in a second. So here you've got a number of different factors. Each of them will either make a river more likely to be flashy and that really quick, sudden, violent flood, or are more likely to cause a slow onset, delayed hydrograph. And what I want you to do is look at them. So something like a heavy, intense storm, that's going to cause a flash flood. That's going to make lots of overland flow. That's going to lead to the water getting into the river quickly and the lag time being short. Whereas gentle drizzle, that's going to actually mean that the water perhaps soaks into the soil, infiltrates into the soil more. There'll be more water flowing through the soil, through flow, or going through the ground flow. So it's going to mean that it takes longer for the water to get to the river. And that's the basic rule. If something is going to increase the overland flow, so it's going to be more water getting into the river quickly because overland flows faster than going through the ground, it's going to cause a flashy hydrograph. And if it's going to reduce the amount of overland flow, it's going to cause a delayed onset or a slow onset hydrograph. So have a go at going through these. Like I say, pick up snow melt. If there's loads of snow melting, is that going to increase the amount of water or decrease it? If the ground's not frozen, okay, so that the water can soak into the soil, will that increase or decrease it? So have a go at going through these. Like I say, if you're not sure, leave them. I'll go through them in a second. All right, you get on with that. And when you're ready, press play. Okay, so let's go through these. We've already done heavy, intense storm and gentle drizzle. Snow melt, if there's lots of snow melting, then there's more water, which is going to cause you a flashy hydrograph. If the ground's frozen, then water will soak into the ground and it'll reduce the amount of overland flow because you've got that infiltration, so less likely to be flashy. If you've got dams and reservoirs, well, the whole job of those is to probably try and stop floods, so it's going to create a slow onset. If you straighten the river, okay, then actually the water travels faster, it creates a flashy hydrograph, just like channelization. If you make the river smooth, you make it into a man-made channel, it tends to create a more flashy profile. Whereas long meandering rivers, it takes time for the water to get there. It's more likely to be slow onset. Now, drainage density is how many rivers there are in an area. And if there's lots of rivers, we say it's got a high drainage density. High drainage density basically means that the water hasn't got long to travel before it hits a river. It's going to get into a river quicker. Those rivers will presumably join together and basically it's going to cause a flashy profile. If it's got few tributaries, we call it low drainage density. Far harder for water to get into a river, therefore it's going to have a slow onset or a delayed profile. Impermeable rock and soil means that the water won't infiltrate or percolate into the soil, percolate into the rock, more likely to cause overland flow. We know overland flow is really fast, gets water into the river quickly, so more likely to cause a flash flood. Conversely, permeable is going to be the opposite. The water will soak into the rock, and if it's infiltrating into the soil or percolating into the rock, less overland flow. Unsaturated soil and rock can absorb more water, so again, there's going to be less overland flow. Saturated means that you can't infiltrate the water into the soil, okay, because basically there's nowhere for the water to go, so more overland flow. Gentle slopes, that will basically mean that the water will travels overland flow will go slower, whereas steep slopes, the water will travel overland faster. Few buildings, again, more vegetation to intercept, less likely to be permeable surfaces. So again, it's going to reduce overland flow, whereas we know urbanization increases overland flow. Again, crops, more or less, will actually reduce the amount of overland flow, whereas bare fields, Okay, say for example after harvesting, when you've burnt the crops to let the nutrients back in, will increase it. If you get rid of trees, less interception. Again, rain hits the soil, more likely to travel over land. And if you plant trees, you're going to increase interception, reduce the amount of water hitting the soil, gives the soil more time to infiltrate, less overland flow. Now, what you notice is that a lot of those are very similar to what we're doing last lesson, and that's why it's really important to understand these are all links. But basically, if you've got anything that's yellow, it's going to make it more flashy. Anything that's blue is going to make it a more delayed and a more slow onset flood. Now, what we're to do is use that information is to draw up a couple of diagrams that look like this. Okay, one for flashy, one for slow onset or delayed, and see what information you can get. Now, what is it about the precipitation? Well, we know for flashy ones, heavy precipitation means that the soil can't absorb it fast enough. More overland flow is going to go on to the ground conditions. If the ground conditions are frozen or they're saturated, antecedent conditions, we know that that's going to increase it. So use that information to try and create one of these for flashy and one of these for slow onset or delay. When you've had a go, I'll go through the sorts of things you should have on those diagrams. So stop the video now. When you've got those done, press play. So let's start off with flashy. So we've got our flashy hydrograph here. We can see that actually the lag time here is well, that was happening after half an hour. It's about half an hour. Yeah, that's incredibly flashy hydrograph. So as soon as it rains here, you have a risk of flood. And if you have a look, you can see here the sort of things, intense rains, snow melt, maybe they straighten the river, it might have high drainage density, impermeable soil and rock, steep slopes, urbanization, lots of it. There might be agriculture with bare fields, lots of deforestation. All of these factors would be typical of this sort of factor. So again, go back to your brainstorm, your sort of mind map, whatever you want to call it, and see if there's any of those you haven't got and add them in. You might want to draw a little sketch of what the hydrograph looks like as well. When you've got that done, let's have a look at delayed onset. So delayed onset, completely the opposite. So if we look here, 1, 2, 3, 4, 5, 2.5 hours between the rainfall and the onset. So yeah, gently going up, gently going down. This wouldn't be a dangerous river to be next to. If it does flood, you have plenty of time to be warned about it. Precipitation, it might be drizzling over a long period of time. There might well be a dam. The river is likely to be natural. Probably going to have low drainage density, few rivers joining it. So the water will have to travel a long way over land before it gets there. Probably heavily forested or lots of crops, dense crops absorbing the water, stopping overland flow, few buildings, little tarmac, permeable rock, unsaturated, not frozen ground, so it can infiltrate lots of water, probably gentle slopes. And notice that these things here will also be a reason why there's few tributaries, because actually most of the water is going into the ground rather than into rivers, so there won't be as many rivers. So again, stop the video, see whether you've got all of those points. If you haven't, add them to your mind map about delayed hydrographs. Okay, well that's pretty much it. Okay, so now your job to do some quick exam practice. So have a go at these questions. Okay, number 1, label discharge urbanised and forest. Which one would have the shorter lag time? So you've got a flashy hydrograph here and a not so flashy, a more delayed one. Which one's going to be urbanised, where all those concrete surfaces, or water gets into the river quickly, is likely to be quite flashy. So you should be able to work that one out. Which one reaches its peak flow first? Well, that's the red one. Okay, it's pretty obvious that. Okay, but can you work out the lag time? These are days. Okay, so there's the peak peak rainfall. There's the peak discharge. There's the peak discharge, the blue one. Can you work out the number of days? Just count the number of ticks between the peak discharge, and the peak rainfall. And why do you think they might be different? You already know that one's urbanised and one's forested, so you could explain that. Okay, you could think of another reason. What about the slopes? What about the drainage density? What about the soils? They might all come into it. So have a go at those. Hopefully that's fairly straightforward. If you're not sure about any, okay, come back to me. And one final sort of challenge question. Some rivers, not many, actually have a double peak. And you get a sort of peak that looks a bit like this. Okay, why might that be the case? Why might you see a double peak on some storm hydrographs? So just have a think. I mean, this one's actually over a long period of time, but even in short distances, you can have a double peak. Why might that be? So just have a think. And the answer you might get a double peak is simply because there's two storms. So it rains once, it rains twice. Or, okay, it could actually be it rained once and then they decided to open a dam and release the rain. Or it could be a figure of eight-shaped basin. What that means is it rains here and the water travels down here and you get a peak. And at the same time, it rains here. And then later on, that same day, perhaps, the water's got there and you've got a peak. But like I say, pretty rare, but like I say, it does happen sometimes in some rivers. And lastly, just before we end, okay, two sentences. Can you come up with a sentence that uses the word overland flow, more flashy hydrograph? And can you come up with interception, low drainage density, and slow onset hydrograph? So there's a challenge. Can you come up with two sentences? So mine would be, for the first one, it might be, I don't know, the more overland flow, the more flashy the hydrograph is. There you go. You have a go at your other one. Right, well, I hope that's been useful. As ever, if there are any questions, okay, please email me, okay, or leave a message on Teams. I'll try and be around on Teams from 2 till 3 o'clock. You can email me and I should be able to give you an almost instant response to that. And if there's anything else we can do, give us an email. But for now, thank you so much. Cheers.